In this video, we're going to go through empirical and molecular formulas. The essential question that we're going to answer is, how do empirical and molecular formulas represent the composition of a compound? So let's begin by talking about molecular formulas. So you've seen these before. We've written out chemical equations. They represent the actual number of atoms of each element in a compound. So in this example, down at the bottom, we have butene, which has 4 carbons and 8 hydrogens. Okay, it is the true chemical formula of a substance. Okay, so just what we've been working with up until this point. Now, an empirical formula is the simplest whole number ratio of atoms in a compound. We've got 2 examples down here at the bottom. We have C4H8 and we have C5H10. So we can simplify both of these, and if we do that, we can divide the first one by 4. So if I divide the first one by 4, I'll end up with 1 carbon and 2 hydrogens. The second one, I can divide each piece by 5. So 5 divided by 1 will give me 1 carbon, and then 10 divided by 5 will give me 2 hydrogens. And look at this. We have the same empirical formula, but we have a different molecular formula over here. So the empirical formula is the simplest form. The molecular formula is an empirical formula times some multiplier, we'll call that n, and that equals your molecular formula. So it is possible for two different molecular compounds to have the same empirical formula, because it is the simplest or reduced form of that formula. Okay, to find the empirical formula, we're going to convert the given percentage composition or mass to moles by dividing the atomic masses of each element. Then we'll divide all values by the smallest number of moles to find the simplest ratio. If necessary, we'll multiply the values by a whole number to obtain integer subscripts. So right here, no decimals in formula. And we're going to do an example where you will see this come up. And then write the empirical formula using these subscripts. Okay, so let's take a look at an example so you can see what we're talking about here. So we've determined the percent composition here of a compound. So it's 40% carbon, 6.71% hydrogen, and 53.29% oxygen. We're going to need to convert these percentages to moles, but in order to do that, we would need to know their masses, but we don't have those. We just have percents. So we are going to make an important assumption here. We are going to assume that you have 100 grams. This is very important. Okay, so you want to assume that there is 100 grams. So if I have 100 grams, 40% of that would be 40 grams. So I have 40 grams of carbon. Of hydrogen, it's 6.71%, so that's going to be, yep, you guessed it, 6.71 grams. Oxygen is 53.29. Just like that. Okay, so we're going to convert these into moles. So let me go ahead and set these up. We're going to, of course, put our molar mass on the bottom because we're starting with grams here. So carbon is 12.01 grams. Hydrogen is 1.01 grams. And then oxygen is 16 grams. And then on top of all of these, it's going to be 1 mole. Okay. So if I do the math here, for carbon, I get 3.33 moles. For hydrogen, I get 6.64 moles. And for oxygen, I get 3.33 moles. Okay. The next step is we are going to divide all of the values that we just calculated by the smallest number. So the smallest number here is 3.33. So I'm going to divide all of these by 3.33. So 3.33 divided by 3.33 is 1. 6.64 divided by 3.33 is about 2. And then 3.33 divided by 3.33 is 1. So my empirical formula would be C1. I'm going to leave the 1 off. H2, because we figured out that number is 2. And then finally O. That is our empirical formula. So that's the process to find it. Let's do another example here. In this example, we have 25.9% nitrogen, 74.1% oxygen. Determine the empirical formula. So let's go ahead and try to do this one. Again, we're going to assume 100 grams. So we've got nitrogen and we have oxygen. Nitrogen is going to be 25.9 grams. Oxygen is going to be 74.1 grams. And we need to convert these into moles. So I'm going to set these up. The molar mass is going to go on the bottom. Nitrogen is 14.01 grams. Oxygen is 16 grams. So again, we are setting these up so that our molar masses are on the bottom, so our units will cancel. 1 mole is going to go on the top. Okay, so we get 1.85 moles of nitrogen. I get 4.63 moles of oxygen. So just like the previous problem, we're going to divide by the smallest number here, which is 1.85. So we put these in our calculator. So obviously 1.85 divided by 1.85 will give me 1. 4.63 divided by 1.85, however, gives me 2.5. So not close to 2, not close to 3. It's 2.5. So if you recall, when we wrote down our steps, if necessary, multiply the values by a whole number to obtain integer subscripts. So we never want to have decimals. So if I were to write this out the way it is right now, I would have NO 2.5. And this is not okay. So, oh look, the formula is no. Yes, no, you can't have that. So we're going to multiply this to turn my decimal into a whole number. So if I multiply both of these by 2, 1 times 2 will make that 2. 2.5 times 2 is going to make that 5. So this is going to be our empirical formula. You cannot have a decimal. So if you need to multiply it to clear the decimal, it's going to be the least multiple that you can use to get a whole number. So in this case, 2 is the smallest number I can multiply by to get that decimal to clear. Okay, so again, if you end up with a decimal, you got to fix it. You can't have it in the subscript. All right, so those are empirical formulas and how to find them. Let's move on to the molecular formulas. Okay, so to determine the molecular formula, you're going to first need the molar mass of the empirical formula. Then you're going to divide the molar mass by the empirical formula molar mass. So in the question, it's going to give you a molar mass. You're going to divide that by the empirical formula molar mass. and then multiply the empirical formula by the resulting whole number. So let me just remind you that the empirical times some number n is equal to the molecular formula. So if I wanted to solve for that n, I would divide both sides by the empirical. These would cancel out. So that multiplier is going to be equal to the molecular over the empirical. And that's exactly what the directions are telling us to do here. So let's go ahead and give that a shot. In this example, it says, given the empirical formula CH2O and molecular molar mass of 180 grams per mole, let's find the molecular formula. So the first thing that we're going to need to do is determine the molar mass of CH2O. So the molar mass To find the molar mass, we're just going to go through and add up the individual molar masses of everything. So carbon is 12.01. Hydrogen is 1.01. There are 2 of them, so I'm going to multiply that. That'll give me 2.02. And then oxygen is 16. So if I add all those up, I end up with 30.03 grams per mole. So our molecular molar mass is 180.18. So to find that multiplier that we need, again, we're going to figure out the, we're going to divide the molecular by the empirical molar masses to get that multiplier n. So n is going to be equal to 180.18 over 30.03. So if I do the math here, that ends up being 6. So that's my multiplier. So I'm going to take 6 times CH2O. So I'm going to distribute that to every single piece in the formula. So my molecular formula will be C6. 6 times 2 is going to give me 12, H12. And then 6 times 1 oxygen will just give me 6, or O6. That is my molecular formula. All right, let's do one last example here. Compound has an empirical formula of P2O5 and a molar mass of 283.9 grams per mole. Determine the molecular formula. So to save some time here, I've already calculated the molar mass. So the molar mass of P2O5 is equal to 141.94 grams per mole. To find that multiplier, it's equal to our molecular molar mass, which is 283.9 grams per mole, over the molar mass of the empirical, which is 141.94. When I do the math here, I end up with the number 2. That's my multiplier. So 2 times P2O5. That's going to give me the molecular formula of P. 2 times 2 is 4. 2 times 5 is 10. That is my molecular formula. So in this video, we went through empirical and molecular formulas, and now you are an expert. Good luck solving those problems.